This is SciByte, episode 65, for October 2nd, 2012. Hi everyone, and welcome to SciByte, Jupiter Broadcasting's weekly science podcast. Live every Tuesday night at jblive.tv, and then fresh for download Wednesdays at jupiterbroadcasting.com. My name is Chris, and joining us every week is our host, Heather. Hey there, Heather.
Hey there, Chris.
Hey, Heather, happy science to you.
Happy science.
All right, so what are we talking about today?
Today we're going to take a look at the scientific excuse to eat chocolate, shifting plate tectonics, measuring a black hole, possible new elements, comets, statues, an update on Google Maps, crowdsourcing science, spacecraft and curiosity updates, and as always, take a peek back into history and up in the sky this week.
Sounds like a heck of a show. Then let's kick things off with the news. Something told me I should have grabbed a chocolate bar before today's episode.
Yes.
All right, give me the science to why I can now eat chocolate to podcast.
Okay, a recent study actually shows that chocolate might help increase your memory.
I'm liking this so far.
I love this part. So, I'm totally unbiased for chocolate, but so there's, you hear all about these superfoods.
Mm-hmm. Sure, yeah.
It's actually kind of an unscientific term. There's not a lot of
that makes
scientific
sense.
basis or studies about this that kind of prove beneficial effects.
Yeah.
And a lot of those superfood groups include dark chocolate, which, I like that part.
Mm-hmm.
But an undergraduate student at the University of Calgary actually became curious about what certain dietary factors might have on memory.
Okay.
So he's like, all right, everyone talks about this chocolate stuff. I don't think it's going to do anything. So he narrowed it out, and he got this particular flavonoid that was found in chocolate, green tea, things of that nature.
Mm-hmm.
So you can't really do this kind of a test on humans because there's way too many other things that are going. There's too many external factors.
A lot of variables in a human.
Yeah. That's, day to day, week to week. It's not a lot of consistency.
Yeah.
So what they did was they grabbed some pond snails.
Oh.
And they got, so what happens is when they're in deoxygenated water, when the oxygen supply is pretty low, they extend these little breathing tubes.
I've seen that, of course, yeah.
So they're trying to search for actual air. So what they did was they had them and they put them in unoxygenated water. They kind of tapped the little shell to make sure they didn't put out their feelers, their breathing tubes.
Okay.
So they're kind of training them. All right, when we tap, don't put them out. Keep your little breathing tubes to yourself.
Interesting. Okay.
So then they fed them this flavonoid, the specific flavonoid.
Uh-huh.
They kind of had a baseline to make sure they weren't making the snails wired.
Okay.
So they're not. Yes. So
science is calling to let you know that
yes.
The snails did actually, in fact, get a little hyper.
Yes, I think they did. So what they were able to do is run this test and see. All right. So in general, they were able to make these intermediate term memories last about 3 hours.
Okay.
But nothing could go for 24 hours or so on these. So after they fed them the flavonoids, they actually, from the dark chocolate, they're able to remember to keep their breathing tubes closed and for over a day. With 2 training sessions, they were able to actually remember it 3 days later, when generally it was a couple of hours. So they're going from hours to days with this specific flavonoid.
Huh.
So it wasn't only extending the amount of time that they could remember it, but how strong the memories were. You have one thing and you have a memory of it, and then you try to override it with something else. So every time the phone rings, you throw a book at it.
Right, sure. That's what most people do.
Yeah. And so then suddenly when the phone rings, now you need to do something else.
Yeah.
And that's,
like yell at your spouse.
Yeah, you do that.
Yeah, sure, you could. I mean, I'm not saying that's what I would do, unless it was her fault again that somebody was calling at this time of night.
Yeah. Well, books might be thrown back at you. But anyway,
that's true.
The whole idea is when you override another memory, it's called extinction, actually. And so the original memory is forgotten. The additional memory is stored, weekly. So there's all these kind of things going on. So with the flavonoid fed snails, they wanted to keep that original memory. It was hard to train them into a different memory.
Oh.
So it was, tap the shell and now put up your breathing tubes instead of put down. And they really wanted to stay with the original memory, the mental training cycle. So it was kind of interesting. And it's not just sensory going on here, like, triggering a memory. I mean, like smell. They have a predators by smell, and that makes them store the memories in a certain way and act a certain way. But with essentially the snail version of half a bar of dark chocolate, it was able to store those memories in a different way. So it was directly affecting the brain and was able to let them remember all these things, longer and have that memory even stronger in the brain. So
this is interesting because, I've heard that some people, like in college, will try specific caffeine regimens. And they went so far that there was a study done that college students who studied for an exam under the influence of caffeine were able to recall the details for the exam during the actual exam time generally better than the average student if they also had caffeine at the time of the exam. If they didn't have caffeine at both times, it didn't work. But it's this interesting idea where if you're doing something, there might be something there might be a chemical that your mind could take, just like there's a chemical your muscle can use when you're exercising, and it maybe it utilizes, you can exercise more efficiently. Right, or effectively. So it's in a sense that your mind is kind of like a muscle in some ways. You're kind of enhancing its ability to perform a specific type of task. And maybe you could take something like this when you're learning, right? Maybe there'd be like a supplement you could have.
Well, yeah. I mean, looking back at college, I had a little bowl of M&Ms and I solve a homework answer, and then and then I allow myself a couple M&Ms. See, that was training regimen and chocolate involved. Look at that. You were saying about the muscle memory. Yeah. That's incredibly true. What was it? I remember in junior high, spelling and me didn't really get along at one point.
Oh, yeah, well, I still have that problem.
Yeah. So during my lunch break, if I had a spelling test, I'd eat really quick and then I'd go to the library. And I would walk around this table in the library in the back corner looking at my spelling words and like repeating them very slowly and just kind of going over them in my head. And then when I get in the test, I'd actually kind of sit with my feet like walking under my desk as like tapping them. Teacher looks at me like I'm completely nuts. But suddenly the letters are coming back to my brain.
Really?
And I was like, you look at me nuts all you want. I'm getting a better grade.
That's an interesting, that's kind of like an interesting little approach. So it's like an association thing, you think?
Yeah. Well, for me, that works that way. I did a lot of theater. So if I had to learn a part at the very last minute because someone was sick or something happened, I would learn everything while I was moving. I was like, all right, tell me, do I need to walk over here and then put this book down? Okay, I'm going to be doing this all at the same time. Like, don't you want to learn separately? I'm like, no. Everything must be connected.
I find with computer systems, somebody can tell me something, and like, okay, use Vi, edit the Etsy rc.local file, and go to line 55 and change these things, blah blah blah. And if it's simple enough, I can grasp it immediately. But if it's a very long, complicated, drawn out process, I can get it the first time if they show it to me. I can watch them do the process, and then I get it. But if they explain it to me, I might have to ask like at a couple stages. Okay, now I do this here, right? And then I do this here. So it's very interesting. Like it's part of it's like if it's visual, but it's visual with context or something. There
are very specific ways, and they have tests and things like, are you a visual learner? Are you an auditory learner? Are you a mix? There's different types of people that work well. Was it my grandmother and my aunt when they went on road trips? It was marvelous for them. One of them could learn just by hearing it, and one of them had to see it. So one would read the map and read it aloud to the other person, and they could get to where they wanted to go. And they just had to, that was the way it had to be. They tried it any other way, they'd get lost and end up in some goodness knows where behind a barn. So it is, and it's interesting how these different...
The flip side, though, I find really wild about that is, so I would consider that, I would kind of label that as me being a visual learner, right? Mm-hmm. But then you take something like an audiobook, and I had this Stephen King audiobook where there's this Southern woman in it, and she kind of had this accent, and she said this one guy's name in a certain way. And this is an audiobook. And I read this book about a year ago. Today, I'm watching a TV show, and I hear a voice that reminds me of this person, and I start visualizing the movie that I saw this person in, and the scene, and what the person looked like, and the clothes they wore, and then I realized, oh, wait a minute, that was an audiobook, so I had this entire visual image, this entire visual construct in my brain somewhere of what that scene was like and all of that. It was all it was all from listening to something, but I guess the way the brain processed it, it still created a visual for it.
Yes, if I read a book and saw the movie for it, and it was like a while back, like from my childhood, I actually have to watch the movie very carefully, because I have two versions of that book visually. One when I read it, one when I saw it. And I was like, all right, no, that scene was in my head from the book. Oh, this scene is actually in the movie. You know, it's just the different ways that your brain processes things and remembers things, and does everybody get affected by these kind of flavonoids the same, and how do you remember? And the brain is really complicated. Really complicated.
Yeah.
So it's all these different ways that can affect and what works for you. And I'd say that learning how your brain, works for you, how you learn things, how you remember things the best, that is definitely one of the most important aspects to doing well, learning things, or in school or anything like that. It's figuring out what works for you. So, and it is all about that. You see something, there's certain smells that, throw me back to a certain place.
Oh, sure, yeah.
And it's all these connections and
or
memories,
songs
and how
can do that.
Yeah, or songs, any of these type of things.
Yeah.
That can work together to trigger a memory. So it's how can you lay the foundations down to, make sure that you have a better chance to hold that memory, and how do you bring it back? And I took this whole story as I have better excuse to eat chocolate.
Yeah.
But there's so much more to it. So it's interesting about, all the different studies that can be done about what can increase and decrease, and how it affects the brain and the memory, and how they all combine together.
Very interesting stuff, Heather. That is one. Now, thank you, snails, for laying the foundation to the science. Now, if they need any human trials, they can contact Heather and I, SciByte, at jupiterbroadcasting.com.
And we will make the sacrifice.
Yeah.
To eat chocolate for science.
Yeah. Maybe we should eat chocolate during the shows, and then on the next show, see if we can remember what we talked about in the previous show.
Oh.
That's a good idea.
There we go.
All right, Heather, well, let's take a quick pause here, and let's talk about actually something that I was talking about on the pre-show before we got recording, something that made a big impact on me and created a lot of memories. So Jupiter Broadcasting shows are funded by our audience, because we kind of have niche programming, and we have sort of adopted this model because it works really well for us, and it keeps us honest and keeps us only reporting to the people who actually consume the content. It's an interesting concept. And one of the great ways we can do that, because it allows you to contribute to the network without really impacting your budget. You just do it as purchases you're already going to make, is through the affiliate links we have. And we often have an Amazon pick, because that's one of our favorite affiliate sites out there. And Heather, you picked a great book this week.
Yes.
Red Moon Rising, Sputnik and the hidden rivalries that ignited the space age. Now
Yes.
you've read the book, and I've listened to the book.
I haven't actually gotten to read the whole thing yet, but I've looked a lot. I've looked a lot about it, and it's definitely on my must finish this soon list.
Yes, you must. I mean, this. Interesting. So I'll talk about the audiobook version because that's what I've got, but we'll have links to both in the show notes. Red Moon Rising. It really helped me understand so much of what I missed out on because I'm just a generation or 3 too late for a lot of what was going on when we really decided to take the leap into space. And it literally starts at the fundamental basics of like the rocket propulsion breakthroughs that we had to have, and like how they had to figure out how to get things just right, and then on from there. And it was one of my first 5 or so audiobooks that I got. Now, mind you, I probably have about 135 audiobooks in my library now. And they're always on demand, which is great. You just pull them down. You can pull them down in files that you can keep for yourself, or you can just keep them in their online storage. And Red Moon Rising was probably like my 5th book or so. And this book is so good that it's what sold me to find. I mean, like, it was like, oh wow, I am all in on audiobooks now. So I just want to play a sample. This is one of my favorite all-time books altogether. Reading it or audiobook.
SS Gruppenführer Hans Kammler suddenly heard a sound like the cracking of a giant whip. They knew, without looking up, that their rocket had just broken the sound barrier, and it was still accelerating, outrunning its own blast wave. 25 seconds had elapsed since liftoff. During that period, the rocket had shed 6,000 pounds. The temperature of the sheet metal covering parts of its outer skin had spiked from 297 degrees below 0 Fahrenheit at the time of fueling to over 300 degrees. The stress on its steel rib cage and interior framing had increased to nearly 4 times the force of gravity.
It's a great, great book. And he goes through that's the very beginning of the book. Or not the very, very beginning, but like the first 10 minutes or so of the book. Yeah. And it's so good. So Red Moon Rising, Sputnik and the hidden rivals that ignited the space age. And it's written by Matthew Brzezinski, I think maybe is how you say it.
I think that's how you say it.
And if you want to grab it on Kindle, you can. It's crazy cheap. It's $9.99 on Kindle. If you want to grab it on Audible, we'll have a link in the show notes. If you're new to Audible, this would be an amazing book to break you in on to see if you want to do this. And here's the cool thing. If you are new, you can get this book for free. Use the link we'll have in the show notes. You sign up. You get this book for free. You can cancel after 30 days. You get to keep the book. They don't. It doesn't deactivate or anything like that. But I think you'll want to, especially when you combine it with their mobile app. They've just added Whisper Sync, so if you have a Kindle and you have a portable device that plays Audible, it will now sync all of them up. And if you have the book edition of this and then you get the audiobook later on, it will sync between the book edition and the audio edition. So it's like perfect for like read the book when you're at home on the couch, and then you get in the car, you listen to the audio version for however long you drive for, and then it just syncs them right back up when you get back home again. It's
very
awesome.
Nice.
It's Amazon's got some crazy stuff, and that is just one of my all-time favorite books. So I know I went on and on, but I mean, I really like that book.
Yeah. Well, even if you like were there at the time and got to live through it, there's often so much in the background going on.
Oh yeah, and so much more has come out. You know, stuff that it was completely classified back then. So
yeah.
All right, Heather. Well, why don't we move on to the news bite? All right, Heather. What is our first story in the news bite?
All right, plate tectonics. The Indo-Australian plate is breaking into 2 or 3 different pieces because of its collision with Asia. It's hitting in India. It's hitting the mountain range and it's slowing down, while the other side is kind of diving under the island of Sumatra. So there's this twisting going on that's actually breaking this, tectonic plate apart. Now, we're talking geological, times. So it's, thousands and millions of years that this will take to go on. But we've actually started seeing some significant parts of this moving. There was the great Indian Ocean quake in April. It was reported like 8.6 magnitude. Now, actually, now they're estimating that it was about 40% larger than it had first been believed to be. So it's hard with the ocean bearing earthquakes about, telling how strong it was. And in addition, this one was a slip strike.
Oh, I've never heard of that before. It's fancy.
Well, it's more, instead of going up, they just kind of strike slip fault. It's when they slide alongside each other. So, the first quake was a major quake, and it disturbed 4 other faults. So in less than 2 minutes, 4 other places in some were affected by this. They were, less than magnitude 5, but the first one, 90 miles long. But what happens, instead of diving one side up, which is, a major, what you're concerned about in the ocean is tsunamis then. But this actually, where the seafloor just kind of slipped 100 feet alongside each other. So say you draw a line across the fault, and then it happens, and one side slips. Now there's 100 feet between one side of the line and another. So then another one, it slipped, 25 feet, and 4 different pieces of these faults, 4 different faults in various perpendicular ways, were sliding and making all these movements. Now, most of the time when a major quake hits, there are some other quakes that hit, elsewhere in the world. Mm-hmm. But for this particular one, there was actually quite a bit more. The number of quakes of magnitude 5 or larger located, ways away, whereas 5 or 6 times the amount within the next week. So it was an incredible increase in earthquakes. So they were trying to just figure out, well, normally this kind of a size of earthquake doesn't really cause that many, large moderately sized earthquakes so far away. But they're thinking it's because of the strike slip geometry. It actually is kind of, instead of staying still, it just kind of jumping up and down, so they're, trying to ride on top of each other or underneath each other. This sliding action kind of causes geometrical stress other places. So it causes a twisting motion elsewhere in the plate. So it kind of domino effects throughout all various faults into the other parts of the world, causing all these other earthquakes. So as they go along, they're kind of seeing this plate, the stresses of this plate more and more starting to break apart. But, it started to deform. It started this whole process about 10 million years ago. As it, hitting the Himalayas, going up, slowing the part where India is, it's slowing down. So, it's been going on for 10 million years. It's just the large quake in April sort of triggered a whole bunch of other little ones. It's so many times with these, it's the energy involved. You have a whole bunch of tension on them. And so you have a major release, and then that kind of causes stress elsewhere to kind of, ease off. Think of it like if I have like a piece of, a piece of fabric or a pair of jeans or something. There's a big rip. They're kind of old pair. So you sew up the major rip, and you strengthen that part. But now all the other kind of moderately weak places, they're getting more stress. So then they start showing, maybe tears. And it's kind of a similar theory in a really basic science kind of cringes way.
No, I follow you.
But so we're looking at this, and it's just sort of, it's interesting for these long geological time frames, in astronomy or geology, looking at such long time periods, that when you see something, happening, you're like, oh, wow, we can actually see this little snippet of something happening. We need to pay attention to that, because this kind of gives you an overall view of a better idea of what's happening on the whole. As far as millions of years go, there's only so good of science. measurements of a certain consistency only go back to a certain time frame.
Yeah, sure.
So you're working in that, in that time frame. So when you see something actively happening, you can make a lot better guesses about what's happening on the longer time frame. So in this particular earthquake of this type, where this strike slip type is actually, they think it is might be the largest of this type ever actually recorded.
Whoa.
Now, there was one in Tibet in 1950 that was recorded, but don't know what kind of earthquake it was. So you don't know if they were sliding or it was going up and down. So you get to a certain point, and I mean, we have historical knowledge about what this earthquake was. And actually, you can go back in time for these earthquakes before you're actually measuring. Sometimes they go into graveyards and they look at the gravestones, and you can see a crack or how bad the crack is, and you can take the dates from these or buildings, anything of this nature, and you can kind of say, okay, this has a major fault. It would have taken this kind of an earthquake for all of these to happen. And so there's one at this time frame, and there's one in this time frame, and you can look at that. You can look at on coastal regions. You can go down and get soil samples, and they've been able to see. I saw one documentary that they went down and they had this huge spot that was a lot of silt, upriver just a little bit in this, coastal region. So like, all right, well, this is a point where a lot of ocean came inland. So there must have been, for that, it's not just storm surge, it's, tsunami speak. So they're able to, and when they were able to hook up the time frames in the west coast of America to Japan. They're able to actually kind of see similar events at a specific time and say, okay, well, this earthquake probably happened in roughly this part of the ocean. It was probably roughly this strong. So there's so many different ways you can go back and kind of extract data, sort of data in historical context. Right. You can kind of guess more information out of it. But this kind of specific, recently we're actually seeing this specific documented stuff. And so we're able to say, okay, well, this is a very known quantity. So we have very strict data set on this. And then we can kind of look on the larger scale, make guesses, kind of plug in the moderate information, by looking at these, buildings or gravestones and soil samples and say, okay, you're starting to kind of bring everything together to kind of for these plate tectonics. So, I mean, it's similar things sort of in astronomy where you're looking at what's happening here or there. This bringing it back into the Earth where you have these long time frames. You're trying to bring it all together as best you can.
Very true. I hadn't thought of it like that. Well, while we're talking about astronomy, I believe our next story is going to help us size up a black hole.
I think so. An international team has actually, for the first time, measured the radius of a black hole.
This is awesome. It
Yes.
seems like black holes are these mysterious things that we talk a lot about.
Yeah.
But there's a lot of details missing.
Yes. So, start off, there's a certain point. Everyone kind of knows the name, quote unquote, event horizon. That's the point where nothing can cross. It's a one-way trip. But there is also this area where you have an accretion disk there, which is a kind of a area of dust and gas making kind of a pancake circling around this black hole. It's because there is some, external force going on. There's how to describe this in a way that science won't cry. So you're getting everything coming together, but it can't all go in at the same time. So think big tarp full of balls, and you had a little hole in the bottom. They're not all going in at the same time.
Right.
They're going through at a slower rate.
Right. They get funneled in.
Yeah, so everything's going funneled in. And so there's this place where the forces of the energy and the static going out from this accretion disk, from the event horizon, kind of hit. So there's this area where there is, this pancake of, like I said, this gas and dust that's slowly feeding into the event horizon. So you get this pileup, and you can take this pileup of stuff, the accretion disk, and you can measure that and get a much better idea of what's going on. In fact, there were some theories that these rotate. So what the rotation is the black hole rotating in a similar fashion. You can tell that by the magnetic fields. You can actually measure the magnetic fields from the accelerating material, and those can create powerful beams. You'll sometimes see in astronomical pictures, a black hole, and there's giant jets coming from it, and you're like, wow. Jet escaping from a black hole doesn't quite make sense, but that's what it's coming from, is the magnetic fields, from all this hot. So some of it is, before it gets into the black hole, is escaping and being jetted out into space, and it can actually deform a big enough one can deform the galaxy itself. But they're able to. Now, telescope we don't have the magnifying power to be able to see this small of detail about a black hole until now. Now, what they've actually done is it's called the Event Horizon Telescope. And it uses this idea of, they call it very long baseline interferometry, which is, what it means is you can simultaneously take a couple of different telescopes. You can take one, say, from the east coast of the U.S. and the west coast of the U.S. So you have these two, and they're viewing something at the exact same time. Now, in specific band of light, the interferometry, you can actually, with those measurements, pretend like the dish is the size of the separation of them. So if you have one on the east coast, one on the west coast, it is like the entire dish is the span of the U.S.
Okay.
So with that kind of large size, now you can look at things in that kind of particular detail. This set, the Event Horizon Telescope, there's one in Hawaii, Arizona, California. There's all these different, very far apart places that you can then use to get details 2,000 times finer than what's capable in the Hubble Space Telescope. So they're able to take all these simultaneously viewed moments, so that everyone records, and they have a local atomic clock that they use, and then they take all the data afterwards. Say, all right, let's line up all the atomic clock data and put everything together, and now combine all this data to get things on a much finer scale. So they were able to combine all this to measure the innermost orbit of the accretion disk. And that thing you kind of figure out as 5.5 times the size of the black hole event horizon. So once they were able to combine all this data to measure the inside of the accretion disk, then they can calculate the event horizon, and from that get the size of the black hole. And they're able to actually, with this, in addition, see the laws of physics suggest that the accretion disk would spin in the same direction as the black hole. And this actually confirms that. It's kind of a direct observation that is looking at the jets coming out and the accretion disk and being able to say, oh yes, they are actually all rotating in the same way. And they're even looking at, adding more telescopes to this array in Chile, in Europe, in Mexico, in Greenland, and Antarctica, and all these different places. And it's how far apart can you get telescopes that can accurately measure something?
Wow, just imagine if we could set up telescopes on Mars and then coordinate them with telescopes back here.
Yeah, that would be interesting.
Or even the moon. I guess I should just shoot for the moon even. I'd be happy with that.
Yeah, I mean, at a certain point, there's parallax. So, if you have, for the Venus transit, the East Coast, the eastern part of the Earth and the western part of the Earth see it differently because there's just a little bit it's the left eye, right eye thing. So you look, hold out your finger at your monitor at arm's length and you look at your left eye and then you look at with your right eye and it moves just slightly. Now with something, so that would be a concern, but with something far enough away at essentially infinity, because of the distance of these, then they wouldn't get a lot of that. So yeah, I hadn't actually thought about that. So set up one on Mars, set up one on Earth, hook it up so that you're working at it when you're on opposite sides of the orbit.
Yeah,
so you have Mars on one side of the sun, you have Earth on the other.
Totally.
Now, could this actually work? That is a question.
Somebody should write in and let us know if they have thoughts.
Yes, if you have thoughts about it, if you know more about this. So, but that would be really interesting. Could that work, and how would the science behind it work? So.
Yeah, absolutely. All right, Heather. Well, then what do you say? It's time for the 2-Byte News. 2-Byte News on SciByte. The 2-Byte News. SciByte News. 2-Byte News on SciByte.
Ooh. One day we'll have an official course.
I gotta be careful.
I think it's more.
I could wake up the family. I get so excited with these jingles. I think if we put any more jingles in the show, I probably would wake up one of the kids. That's probably what would happen.
Probably. Then it would be not, science show. It'd be the jingle show.
Yeah, that's true. That's true. It'd be a morning zoo show then. All right. Well, what is our first story in the 2-Byte News?
Alrighty. Element 113. Japanese researchers have claimed that they have conclusive evidence of this element that they've been looking for a long time now. Super heavy, super unstable, near the bottom of the periodic table. So for these super heavy elements, they don't occur in nature. They have to be produced in a lab using particle accelerators, nuclear reactors, ion separators, a slew of complex equipment.
Okay.
And they don't last for long. You have a very, very short time scale. So they've been hunting for this specific element for 9 years. Now, there's been evidence of it a few times, but this is the clearest set of data they have. And Japan is kind of excited about this because most of the elements, the heavier elements, were America, Russians and Americans working together, Germans. So this would be the first of these super heavy elements that Japan would have discovered. And should the International Union of Pure and Applied Chemistry, say that this is actually true and they accept it, then they would actually get to name it. So they're kind of looking forward to that.
Oh, I wonder what they'll call it.
I don't know. I don't know if they know yet.
Yeah, maybe.
They probably have a whole slew of ideas, but.
Wonder if they want to call it SciByte.
What
do you think?
SciBytium?
Yeah, there you go. Very good. I'm glad you iterated on that. I needed that.
So, okay.
SciBytium.
So if it, just in case any of our listeners are these really, really smart people speeding zinc ions into 10% of the speed of light and smashing them into bismuth, then, SciBytium. Totally random idea.
Just put it out there.
Yeah, just saying.
Just putting it out there.
Yeah.
All right, okay. Any other thoughts on that one?
No, one thing I did find interesting is that elements 93 to 112 had been discovered. And then some recent elements, 114 and 116. So it's not like we're discovering them, 93, 94, 95. It's all about the number of electrons there. So it's seeing what is caused off from that. So, we have 112, we had 114. So this would be 113 that possibly is discovered. Then we're missing 115. So it's kind of interesting how we kind of discover these and how they come about.
Yeah, absolutely. Now, this next story is interesting for anyone that might suffer from a little dyslexia.
Yes, just a brief note on this. I Twittered it, actually. I saw that there is this app that you can put on your iPhone, your Android, your Kindle. Now, for dyslexia, it is a grand wide. It works differently for pretty much everybody. Mm-hmm. There's people who, flip the whole word, flip letters, just various things, flip specific letters or numbers. And for some people, you have to go about combating that in different ways. Now, for some people, having this bottom-heavy font so that it's, kind of the ink is essentially thicker on the bottom of the letters. Yeah. It helps them keep everything in line. So there's somebody who's gone through and made a whole font of this bottom-heavy text and put it out there as free, so you can put it out there and you can apply it to everything. So hoping to be able to help people to read it easier. So kind of combating dyslexia for some people. And it's, if you have dyslexia or know that somebody with dyslexia, it's all, why not try everything?
Very cool. And link to dyslexicfonts.com in the show notes. You can download it as a system font, so you can set it on your system if you have trouble. But it also looks like you can use it as a web font if you want to set it up on your website. So, gosh, that's really neat. They've even made provisions if you want to embed it into a mobile app. They have also so what is this? So what does their iOS app do? Oh, okay. This is really neat. So what it does? Okay, so they have a it's a web browser. It uses the Safari browser that's built into iOS, but it gives you all the fonts in bottom heavy. So if you have a hard time reading the web on an iOS device,
yes,
then this will be a way for those folks to do that.
Yeah,
and it's free. So I'll have a link to that in the show notes too.
Definitely, I know people that have it, and they try.
I
try whatever
if I have it sometimes, because people have got to notice, I just cannot pronounce anything, and on top of that, I have the hardest time reading emails, out loud. Yeah. Out loud. I can read them personally. I don't know. Maybe I think what it is I have a slow brain. I don't think it's dyslexia. I think it's just slow.
That's all. Well, the person I knew was flipping B's and D's and 2s and 6s, and they saw them in various different ways. So I've known people who've flipped the whole word. So it's kind of interesting about some people put colored clear colored see-through plastic on top, and it helps them. But this is one that I hadn't seen before, and especially since it's free.
Yeah, that's great. Good find, Heather. Good find. All right, so let's talk about a comet.
Yes. All right. Astronomers do not like to predict the future. We do not like to predict the future. All we know is that there is a comet that will probably be around in the sky next March. Now, that is way far away. But if, there's a whole range of what could happen. One, it's going to pass pretty near the sun. It could pretty much just crumble, collapse, and be nothing. But if everything works out, it could actually be one of the top amazing comets for recent. It's if you remember Comet Hale-Bopp from 96.
Oh yeah, of course.
So this would kind of be similar to that. So we've actually seen it. We have a little picture of where it is now, and it won't be very exciting because it's just a big chunk of dirty ice.
You're wrong. It's thrilling, Heather.
It is thrilling orange little blob. So eventually that orange little blob of dirty ice will swing by the sun, and then it will come close enough to Earth so that we'll actually be able to see it. Now, let's all hope that in SciByte March 2013, when I say the looking up every week, it'll be, oh my gosh, the comet's still there. It's awesome. Now, the grandest idea would be that, it would be really bright in the sky. The tail would go half across the sky. It would be visible in twilight. So we'll see. And now that the more you predict that, the more it's likely that it will just kind of break up into a million pieces as it passes the sun.
Not. Hopefully we'll get a show.
So just kind of I saw that and I was like, I don't want to jinx it, but it's kind of interesting that we've got one of these coming by.
You're not jinxing us. That's not, no. See, all you have to do is if you just keep us posted, then it's keeping tabs. If you put it out there once and you never talk about it, that's jinxing it. That's the way it works.
Whenever I find more information as it gets closer and astronomers are actually willing to say anything about the future, then hopefully we'll all be having more things interesting to say about this.
All right. Well, something that I think you can add, like food, like you add a little salt to most things, it makes it better, right?
Okay.
If you get something from space,
Yeah.
that's awesome. So our
Yes.
next story is perfect.
Yes, so this 1,000-year-old ancient Buddha statue, which was originally recovered in 1938, has actually been recently analyzed by scientists, and it was found to be carved from a meteorite.
Statues from space.
Yes.
What?
So it's kind of known as the Iron Man, weighs about 22 pounds, and it's this stylistic hybrid between Buddhist and pre-Buddhist Bon culture. Very cultural. I'm not going to make that science cry. But it was originally discovered in 1938 by an expedition of German scientists. And
Nazis, right?
yes, probably taken because of the...
They were Nazis.
No, in ancient Indian, their specific cultures, it's the Nazi swastika is actually from a reverse of that.
Okay.
Of a original swastika from that. It's sort of from Indian culture. I believe it's good luck or something.
Okay.
So they kind of stole that, and because of borrowing that, thinking that the Aryan race came from India, all sorts of fun Nazi crazy science. But they got it, question mark how. It amazingly came back with them to Germany, and it finally came up for auction in 2007 where it could study. So able to, go to this and study what it is, what it's made of. They would classify it as a taxite. It's a rare class of iron meteorite, high contents of nickel. So they're able to say, all right, this is the exact composition of this. That is a meteorite. That is this specific type of meteorite. And in fact, they can hook it up to a crash in the Mongolia-Siberia area, like 15,000 years ago.
So this statue is 15,000 years old?
No. That was when the meteorite fell.
Oh, okay.
Then, somewhere along the
cool.
line, somebody chiseled out a fragment of this and, tromped it across and, carved a statue into it about 1,000 years ago.
So that kind of would indicate that 1,000 years ago, somebody had the wherewithal to recognize that was a meteorite there and specifically seeked it out. And what I would assume would be no easy task to get a good chunk of rock from, to carve from. There's a lot implied there. Am I following that though?
Yes. If you think about it, anything from space, anything was, from the heavens. When these rocks came down, there was two camps. The Earth is ending, and somebody is mad at us, or, oh my gosh, let's go get that. It is from the sky. It must be amazing.
Well, they're right about that part.
Well, yes, they're obviously right about that part. So you go and you have, somebody maybe took a chunk of this rock and it was just it was just there. And then finally, somewhere in between that, when it got chopped off, I'm not quite sure if they know even, then 1,000 years somebody was able to carve out the Buddha statue. So another interesting part is that you've actually able to see other debris from this specific meteorite, the origin of it. In 1913 was the first official documentation of it by some gold prospectors. So it's also in some kind of interest into that. So when was this? This is the first discovery of this specific meteor that fell. You can look at this, and it's kind of interesting because now they're looking at the price. And so often with these, meteorites and things of very specific, or nothing's like it nature. How do you price that? You don't really price that. They're looking and they're like, okay, well, there is no other
right.
ancient human engraved statue made from a meteorite.
Yeah, it makes gold look quaint.
You're like, how do we...
Oh, that's
make
diamond?
that?
That's adorable. This is
Yeah.
meteor rock.
Oh,
I mean, come on. How do you beat meteor rock? Because not only is meteor rock rare, but there's each meteor rock is rare. Each individual one. So that's a good little prize they have there. Now, so who owns that? Do you know whose hands that ends up in now? Is it private or is it in a museum somewhere? What's the...
I believe currently it is probably private. I believe the private person who got it in auction in 2007 is probably the one who said, okay, now I'm actually going to admit, I'm going to bring this out to the scientific world. I'm going to say, all right, you guys, check it out.
Wow.
And that's what happens sometimes is these things are in private collections. And then it has to kind of pass around to somebody who's willing to bring it out into the public and say, all right, now this can be analyzed by science. So I just kind of came up along the way that in the end it's taken to now, and we kind of see that. And so it was one of those interesting little bits of information. I was like, they've kind of discovered this, and now that they've narrowed it down and they're able to say, this is this specific type of meteorite. Now it's from a chunk of one, obviously. Now go back and say, all right, what kind of meteorite of this nature fell near this area? Then they're able to say, all right, that must be from this crash 15,000 years ago. So it's interesting how they can kind of backtrack all these to a specific origin as well.
Yeah. Yeah, that is really neat. That is really cool. All right, Heather, well, I've got good news. We've got a few news stories that have leveled up. That means we've got updates.
We do. Talked about crowdsourcing science a couple times, where there is online website where you can go and say, all right, various things like on Mars, you can say, this is a rock. In stars, you can say, you can see the brightness level. And we've talked about Kepler, how you can spot planets by watching the dim, the dip in the light every so often. So you can go through and look at stars and say, here is a dip, here is a dip. Oh, right. Yeah, this looks like it's something very regular.
Yeah.
And if enough people upvote that, then it goes into a different layer. And so you can kind of weed through this giant set of data by everyone going through it and kind of
using their built-in pattern recognition, aka their brain.
Yes, because the human brain is really, really good at pattern recognition, way better than kind of science. So, or computers. So now that they have a different one, they now have a one that's for the Cyclone Center, which is essentially hurricanes. Oh. So able to look at and see like this is this stage of hurricane. This is kind of this part of it. And actually, the one I saw was they kind of spit out like 6 different images. It ended up being of the same storm at different times in its life. So I was randomly picking and saying, all right, this kind of looks, and of course they'll have, this is what an eye wall, you click the question mark and it'll show you a couple pictures.
Yeah.
So you kind of see, like, okay, this most looks like that kind of a picture, and line everything up.
Yeah.
So this is just another one of those interesting ones that now they've had, one's in space, one's for weather, this kind of thing. This is the Zooniverse. There's a whole slew of these type of things on that website, which link in the show notes.
This is neat.
That you can go through and you can say,
I could do this for hours.
Yes, I have to be wary of these sites because I can get really caught up in them.
Oh, man.
If I'm not careful. So there's these weather ones, there's space ones. I've even seen similar of this type where they've scanned in captain's logs from ancient ships.
Oh, cool.
So then it's you read and you go along and you read the handwriting and kind of type in, this is what I think the handwriting is saying. This is, the barometric pressure for this day is this. They see sunny, they see cloudy, and you kind of select that all out.
Huh.
Because computers have a hard time reading handwriting.
Yeah, well,
especially
on mine. You should see mine, Heather. It's not even. It's awful.
Yeah. Well, humans can sort of read it most of the time, kind of maybe.
Well, my wife, Angela can, yeah. And sometimes, no, that's about it, really.
Okay. Well, it's,
I kid.
you know,
I kid.
most
It's
of
not
these-
that bad.
most of these captains have handwriting that, a chunk of people can read.
Yeah.
So then it's all about having these huge data sets that you can narrow down to a specific way in such I can go on and say, all right, this looks like that, or this handwriting says this. And you get enough people together and you can go through all this data and kind of move it up the line. And so then, a team, this team of scientists and engineers, which now doesn't have to be all that big, they can go through and say, okay, all of these pieces of data, the people say is interesting. Now let's go through it. So then they go through it and they're like, oh, yes. And sometimes for these, you get, recognition for if you're the first person who kind of upvoted it.
Yeah.
So it's interesting science you're putting forward into a team, and sometimes you get a little recognition, and so it's kind of fun. It's addictive game science.
Yeah, it is. It is, and you could call it a time killer, but at least you're kind of helping science.
Yeah.
Yeah. All right. Well, this next story is an update on Google Maps, which just seems to always be taking it up to the next level.
Yes. I believe last time we talked about this, they went through the Amazon.
Oh, yeah, that's right.
You're going through the pass on the Amazon. Now they have one for the Great Barrier Reef.
Yes.
This is the first underwater one that they've done. So that it's kind of interesting because there's a video that you can actually see of what they did, and they had a scuba diver and a little camera, and it was, propelling him along essentially.
Yeah. Oh, so
you're just gonna hang on, and it's flying him through.
That's the same camera they have on top of their cars.
Yeah, very similar.
Yeah, well, it looks except for it's waterproofed and inside of it. Yeah, inside
waterproof, and it has a little jet on it, or not jet, a little propeller, so it's kind of pulling.
I guess
the scuba diver along.
It's that multi. So they're taking a 360-degree picture as they go, which is really cool, and then they stitch it all together. But this rig that they've assembled it on, this underwater camera rig, this is really cool. This is something I wonder if they must have had that custom built.
Yeah, well, they're going through, and it's a combination of Google Maps, and they're working with the World Wonders project, they call it. And they're specifically going through and saying, all right, we have this list of places we want to go through and film, so that people can just click on the web and say, I want to go to the Great Barrier Reef, because I'm probably not going to be able to do that on my vacation. Just me. This little corner of science, not going to be going there anytime soon. But I can go online, and now I can literally kind of, flow through these, throw through and see, manta rays and sea turtles and boulder coral that could be hundreds of years old.
I just heard a very sad story that they're saying that 50% of the Barrier Reef has been destroyed in the last 27 years.
Yeah, there's various numbers about what's happening to the Great Barrier Reef. So it's another interesting point. Was it for NASA? As right before they shut everything down in Florida, they went through and they got all this, the video of where everything was.
Yeah.
What it looked like. And in the vehicle assembly building, they actually had one of the shuttles still sitting there when they went through with the cameras.
Right.
And now, like the day this show was being filmed, some of those buildings aren't there anymore.
Right.
So you can go back and you can see things, as they were. So you can go, you can see it. So maybe it's something you can never go to yourself. Maybe it's something that you just want to preserve that moment in history for.
Well, I think about it in terms of like kids, and I could show my kids at home or schools, really.
Oh, incredibly so. You can look at this kind of a school trip. It's like, alrighty. Yeah. Well, we're not leaving the school today, but you're going to see the Great Barrier Reef.
What's neat is I think it's all HTML5 too. I don't even think it requires Flash. So I mean, it just works on mobile devices. It works on very basic library computers. Mm-hmm. They don't have to have a lot of horsepower. It's really impressive what Google's doing for free. And there's you can expand the sidebar, and there's some ads, but
well, yeah.
But come on. That's not so bad.
Yeah.
Very cool. Very cool. Of course, Heather has gone through and picked a few of her favorite spots and linked to those in the show notes if you want to check them out. And there's some good spots to explore. Those are like it's like a little starter kit.
Yeah.
I like that. Oh, listen to that. It must be time for a spacecraft update.
Yes, the Dawn spacecraft. They went to see the asteroid Vesta and is going on now to see the asteroid Ceres, which is the largest asteroid in the asteroid belt. But it finished all its imaging and its data recording from Vesta. So now they've got this slew of data that they're starting to go through. And one of the things that they were kind of very surprised by when they got there are these big troughs in Vesta. And so it's like these huge faults. Now they're thinking that it could have been formed when another asteroid smashed into the South Pole. There's some very obvious large craters that this thing just got smashed with. And now and there's some other data that indicates that this could have had a layered interior, which means it had, a liquid core, a solid exterior. So something that has larger bodies, like planets and large moons. So it shows that it could have had some of those qualities. Now, they say, okay, it could be from this collision, and they see that there has, the rock surface on Vesta was once molten. So all these different things are kind of pointing to the fact that it had a molten core and layers similar to the Earth. If you remember geography class and you see the Earth and there's all these, concentric circles going in, so you can see all the different layers of Earth. And it's similar for other planets, other solid bodies planets, and larger moons. So now it looks like Vesta had a very similar quality. These troughs are huge. They're, the size of the Grand Canyon. So it's possible that it's just that it was ductile enough that, it was able to move and stretched under a lot of pressure. It's also possible that when it hit, it kind of broke the crust apart and interior magma came up.
Huh.
It filled that in. It looks very similar to those kind of faults here on Earth. Now, if all this kind of comes together, what kept it from being a planet or being called a mini planet, essentially, was that it wasn't very concentric. It was kind of more potato than spherical. So that was one of the major things that kept it from being called a dwarf planet. But if it's shown that it had this mantle and core, which are qualities reserved for planets and dwarf planets, then it doesn't really matter what its shape is now. It would be classified as a dwarf planet. Just one that got the snot hit out of it. It just got hit and just got squashed into a different shape.
Right.
So maybe it got hit and got into a different shape, or it was hit and everything heated up like, say a piece of clay or a putty. You mash it around in your hand long enough and it gets warmed up, and then you set it down on the table. Now, for some of these, it'll kind of sort of melt-ish down, so it doesn't have this spherical shape anymore. It's kind of deforming because it's soft. So that could have been what happened, is it was just so soft after it got hit, is that the hit also kicked it up to this incredibly fast spin. It rotates every less than 5.5 hours. So it's possible it got hit so hard that it broke it up a little bit. The crust broke up, magma came up, and it started spinning so fast that it kind of bulged out. So it got hit and it forced it to spin fast enough that it wasn't actually maintained as spherical shape. It kind of bulged out a little bit along the equator. So now they're going back and they're really carefully looking at all the data, which will take a while to go through. Essentially, when you have this kind of a flyby, it kind of hung out at Vesta for a little while, and now it's moving on. But you get as much data as you can, much faster and much more than you can actually analyze at the time. You just kind of store it all on hand. And now it's moved on and it's headed to Ceres. So now the team that's going to analyze all the Vesta data is now kind of sitting down and going through all of that. So it'll be interesting as time goes on, the further information that they get from this and what they can say about Vesta's past. And did it start off as a baby planet, essentially, that
kind of got a rough shake of the dice.
I got a rough...
Kind of got beat up by the solar system.
Yeah, got beat up and wasn't able to get into a planet.
I have a jingle I could dust off here.
You do. Yes, you can. You can jingle.
All right. Good news then, everybody, because that means it's time for a Curiosity update.
And liftoff of the Atlas V with Curiosity.
Touchdown confirmed. We're safe on Mars.
It's a wheel. It's a wheel.
Yes. It's down on the ground. We actually see pictures.
Yeah. And
all right.
What do we have this week?
So Curiosity has made its longest drive for itself. It made about 160 feet in a day. So in total, it's gone about a quarter mile now.
Okay.
So it's moving. Now, they move slow because you have to be careful when you're driving something on Mars. So you got to be careful. And there's a lot of, stop, and we tested all the instruments for a little while. You stop and test a certain rock or a specific sample. So it's not going to go all that fast, but they've now had their longest drive for them.
Okay.
Able to see, we had, if you remember last week or the week before, we talked about they're able to actually, from the mass cam, spot Phobos passing in front of the sun.
Yeah.
So like a mini eclipse. And they've actually been able to spot it in the daytime now. So it could be the first time that Phobos has been seen during the day.
Oh, really?
On Mars. So they kind of looked it up. They had to, tweak the photo just a little, kind of get the contrast out to be able to say, oh, yes, it is right there. You can see it. So they've actually able to see Phobos during the day. And if you've been watching the news, you may have seen, science news, that they're actually able to see evidence that they're in or driving around an ancient riverbed.
Yeah, now this is what I've heard the most about.
Yes. So there's pictures, and you can see it's essentially almost looks like someone jackhammered up a slab of city sidewalk. So it's it's up on an angle, and this specific type of sand and gravel and pebbles crunched together in this nature is indicative of the riverbed here on Earth. It looks practically the same.
Yeah.
And it's interesting because from this, you can actually guess by the size of the pebbles and how rounded they are, the depth and how fast the flow was going. So you can say, so that from that, they're able to say, all right, these have very rounded edges. So they obviously were able to go for a ways and down a river and round out. And from the size of the largest ones, they can say, okay, well, you had to have water traveling fast enough to be able to move that size of rock. So they're able to say, all right, it has to have been flowing at about 3 feet a second. And they're able to guess from the layout and from those rocks that it was probably ankle to hip deep. Now, it's interesting because you can go through, and there's been, they made this, oh my gosh, first ancient riverbed on Mars evidence. Now, all right, we're able to kind of see evidence of water on Mars for the Viking missions in 1976 or so.
Right, okay.
But as we go through and we're able to look at more data, and you're able to say, okay, well, this is, now we have evidence that we can see this specific mineralogy that's made with water. Awesome. Now we can say this plane was kind of soggy at one point. And we can see in the orbital data, this rim, the crater rim, and then there's a little block in it. You can see like a river essentially coming down from it, and this whole area that looks like a so that this is where all the river came out into, and it spread out in this area.
Yeah, totally does.
So it looks very much like that from Earth. What this says is it couldn't have lasted a very short period of time. It wasn't just a flash burst. This had to have been going for a specific amount of time, and it had to move along a riverbed to round out all these rocks. Now, in one of the videos, you can see little blue lines. And that's probably what happens is, think of it as the Mississippi or something, where you have this river that kind of moves over time. So maybe it was this river delta. Here's the main river, and then it kind of spreads out into this delta. And then the river after that point maybe moves to different parts at separate times. But this is, they could definitely see these and say, yes, this river was there for a while. It wasn't just a one-time event. It was flowing for a little while, 3 feet a second. It had some depth to it. So it's just another one of those interesting footnotes in the history of water on Mars.
And it's right near Curiosity's landing site.
Yes, they actually seen two pieces of evidence about this. One, when they landed, they saw some rock that was upturned from the jets, from just it landing. They're able to see it, and they're like, that kind of looks like this. And now they've driven by another one of these that they're able to get much closer and actually use the cameras to get a very detailed view of these and say, okay, yes, this looks pretty much exactly like what we see on Earth in this case.
Wow. Well done. I mean, they planned that well.
Yes. Well, some things aren't planned. Some things are really lucky.
Is this one of them?
Well, they specifically landed in this type of area.
Yeah.
Because
they figured out a shot of stuff like this.
Yeah, because they're shot of this. I mean, it's still headed to, the Mount Sharp because it has specific qualities that are most likely to have shown did, green goo or something grow there at one point. So
it's called algae, Heather. It's not that gross.
Well, it could be moss or goodness only knows.
Well, step into the time machine because I just recently tidied things up. Let's head back in time.
Look at that!
Oh, here we go.
Here we
go. Yeah, I know. I did. Oh, good. Good. We're gonna make it. See, I was a little worried. I actually forgot to charge the battery.
Oh my gosh!
So luckily, only 55 years ago, October 4th, 1957.
Yes, Sputnik. It's one of the reasons why our book choice of this week.
Oh, perfect. Yeah.
Yeah, the space age began. The Soviet Union, to the dismay of the U.S., launched Sputnik, the first man-made satellite to orbit the Earth.
I'm sorry to interrupt, but just with the Sputnik thing, I had no idea really until I really read this book how big this was.
Oh, yes.
Yeah.
I mean, all it did was a big, shiny,
it beeped,
sphere
and it
that
beeped.
that beeped a radio frequency and circled the Earth every 95 minutes. And that kind of freaked everyone out.
Yeah, yeah. Well, because they didn't know first of all, it was a huge feat to begin with.
Yeah.
But, if it seemed like, well, if they could do that, what could they do next? And at first, people didn't know what it was.
Yeah. I mean, all you see is this little, this is before satellites, before, these high altitude airliners. So you see this little dot flying across the sky, and they're telling you it's transmitting a beep.
Yeah.
That's
and what's great is that book connects the dots from how you go from Sputnik, really how you go from World War II to the moon landing. They really connect World War II to the moon landing. Sputnik plays a huge part in all of that.
Yeah.
Wow. And you think about this, 55 years ago is not that long, and we went from Sputnik to DirecTV and all that stuff. I mean, we've really gone a huge leap.
Well, I mean, look, 57 to 69. I mean, in 57 we launched Sputnik and went, oh wow, we've put a 180-pound satellite into orbit. And in 69, oh awesome, Neil Armstrong and Buzz Aldrin are skipping around on the moon.
Yeah. 55 years though. It really is a lot of progress in 55 years. All right, Heather. Well, that's good for looking back. Now it's time to look up into the sky this week.
That's right. On Wednesday, before sunrise, Venus is going to pass very close to the star Regulus, which they're pretty much just as bright as each other. And they're going to be so close you'll need binoculars to be able to separate them. So it's going to be this huge bright so you'll be able to see them just before sunrise on Wednesday. It's actually going to be Venus and Regulus, so two things together. Also on Wednesday, about in the night, about 11 p.m., the Pleiades star cluster will be to the left of the moon. It's almost kind of looks like a little blobby blur. Depends on how well your night vision is and kind of where you are at, how much city lights you have. But there's just a group of stars very close to each other. And so...
That sounds like a smartphone. I thought you didn't have a smartphone.
I have a phone that beeps at me.
Oh, so it's being a dumb phone.
Yeah, it's a dumb phone. So, and Friday, you'll actually be seeing about 9:30, 10 o'clock, Jupiter's going to be rising in the east-northeast.
What?
Yeah, got Jupiter. And last quarter moon's going to rise just below Jupiter. And in general this week, we've got Venus coming up about 2 hours before sunrise in the east-northeast. By dawn, it'll be high in the east. Mars this week will be in the evening twilight, real low to the horizon. Also in that general area is the red star Antares, and Mars will be to the lower right. So Mars is down to Earth compared to the star Antares. Jupiter this week about 10 p.m. and the east-northeast. To its right is another fainter star, orange star Aldebaran. So we've got a lot of confusing orange stars this week, and Saturn is going to be at sunset this week. Barely visible in the sunset. It'll just be it, and Mars will kind of be out there, but they're going to be very washed out, so it's going to be a little hard to see them now.
Okay. Keep an eye out, though.
Yep.
I can do that.
Yeah.
Well, there we go. That's the whole show, isn't it? Wow.
I think that's the show.
Big show.
Oh, my goodness.
This week. Well, Heather, where can people find you on the... I know you're on the tweeters. Tell people about that.
I'm on JB_Mars_base.
There you go. Of course, you can email any thoughts or feedback to SciByte at JupiterBroadcasting.com. You can join us live on Tuesdays at 7:30 p.m. Pacific, which I believe that would make that 11:30 p.m. Eastern. Boy, it's early in the morning at places in the world, except for in Sydney. Yeah. It's like 2 p.m. So you could always join us if you're, or 1 p.m., 1:30 Sydney time, whatever. Anyways, everyone, SciByte's available for download every Wednesday morning over at JupiterBroadcasting.com. And then, of course, we come out every single week. So if you can't join us live, you can just grab it on the download. Thanks, everyone, for tuning to this week's episode of SciByte. And we'll see you right back here next week.